Broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's webinar, which is focused on fire safety technology trends. I'm Ann Cosgrove, the Editor-in-Chief of Facility Executive Magazine, and this webinar today is presented by Edwards. Before we get started, I would like to cover a few housekeeping items with you. Please note the control panel on your screen. This is where you can submit questions in the question box in that panel. You can send your questions in for speakers at any time, and they will be addressed after the presentation. Also, please note the orange arrow on the left side of your control panel. Clicking on that will either expand or collapse the panel, so please be sure it is expanded so you can access the question box. Also, if at any time you experience a technical difficulty, you can send a message to us in that question section, and someone will address you privately right away. Also, if you're interested in continuing education credits, please note you'll receive a certificate of attendance in an email from Facility Executive after this webinar, and you can report to your association for the continuing education credits. So first, I'd like to introduce your speakers. Your speakers today are Brian Coyne, Chris Hill, and Rick Wolf from Edwards. Brian Coyne is the product management leader for Edwards, a part of Fire and Security Products, a unit of Carrier Corp. And since joining the industry in 2006, Brian has held various commercial roles within the fire and security businesses. His primary responsibility currently is to manage the portfolio of Edwards commercial detection and alarm fire systems. You'll also hear today from Chris Hill. He's the notification product manager for Edwards, also a division of Carrier. Prior to working in the fire industry, Chris worked as a product manager and program manager in the commercial door hardware industry. He has a background in engineering and is passionate about solving customer problems using innovative product solutions. So we'll hear from him again as well today. Rick Wolf is your third speaker today. He is senior product manager for Edwards, and he's held various engineering and product management roles over his 34 years with Edwards. His primary responsibility currently is to manage the portfolio of the company's commercial detection products, which includes smoke, heat, carbon monoxide detection, and building interfaces that create a complete fire alarm system for your facilities. So before we hear from Brian, who will kick off the talk, we're going to have a poll, and that will appear on your screen momentarily. We'd like you all to please take a moment to cast your vote there according to your experience, and then we'll show the results. And as you can see, the question is, which of these is your biggest challenge in managing your life safety systems? So please select one. And the choices are keeping up with changing codes and standards, meeting the changing needs at my facility, maintaining cybersecurity, or managing a limited budget. So please share with us what's your biggest challenge with your life safety management, and we will share those results momentarily, and then we'll hear from Brian. Okay, so we will pop those up in a moment, and let's see. 42% was the leader with keeping up with changing codes and standards. Well, we'll hear about some of that, about that today. 28% followed by meeting changing needs at the facility, 26% budget concerns, and 4% cybersecurity. So thank you very much, and we'll hand it over to Brian. Hi, Brian.
All right, thanks, Ann. And interesting to see those results. We are going to actually touch upon all of those and talk about what Edwards' response has been to some of those. So good afternoon. Today, my colleagues and I would like to take some time to talk about 4 hot topics that are affecting the fire and life safety industry. Topics that we're going to cover are, first of all, codes and standards. So that was the first question there. Glad to see that a lot of you are finding that to be a challenge as well. But as we continue to change how detection, notification, and control panels behave and operate, the next one is flexible site plans. So we're going to talk about how to address how building design changes are becoming more complex than ever before in terms of their device interconnectivity and panel-to-panel networking requirements. We're going to hit on cybersecurity, which covers new requirements related to fire alarm interconnectivity onto building management systems and other external devices, and the susceptibility to attack that you have with that. And then finally, backwards compatibility. We're going to touch upon the concerns that you had there, and some of you shared with managing that limited budget, and how it comes to managing the cost associated with a fire alarm, and how we can help with that. Okay, I think everyone would agree that the only constant with codes and standards is that they're continually changing, and that we're always having to maintain compliance to them to stay in business. Not only us, but obviously end users and building owners out there as well. There are a wide array of requirements globally that we need to meet, not to mention the local requirements that are on top of those. These changes affect all elements of a fire alarm system, whether it's a new fire testing requirements, system survivability, or listings with different regulatory agencies. Things like updated strobe outputs, which are different in the U.S. when compared to other parts of the world. There are other requirements around the panels that are things such as the event queues that are, when compared to the standard 4, alarm, supervisory, trouble, and monitor, included on those fire panels, which are required by UL 864. At Edwards, we've responded by designing our new ESD4 system with the ability to accommodate more event queues to ensure that our customers comply with specific building requirements unique to their region. And then we've also added support for additional networking topologies and things like digital audio messages to ensure that our systems function as expected during emergency events. So many codes and standards changing constantly, and our systems need to be maintained and updated to make sure that we're meeting those changes. When I look at this collage of building images, I'm reminded that no two buildings are alike, each with unique requirements, which presents challenges to all fire system manufacturers when developing products that must adapt to them. Fire systems have to be designed and developed to be easy and install to use, all this while being cost effective. Systems have to be easy to retrofit while using much of the existing wiring and adapting to more than the traditional Class A and B panel-to-panel network configurations. All this has to be done while meeting the latest codes and standards. And at Edwards, we've responded to this by making our systems, and in particular our new ESD4, modular, which means capable of being installed in many configurations. Modular designs allow customers to only install the equipment that is required by the facility and help keep costs in check. We've made our system flexible enough to accommodate many types of network topologies, which include mesh, star, hybrid, and many others. And nowadays, systems have to be designed with the capability of communicating with external devices, such as building management systems. Remote connectivity with the ability to remotely retrieve system status is also now popular and in many cases a requirement. This, of course, opens the door for fire panels to connect to external systems, which comes with its own challenges, in particular the threat from bad actors looking to access unprotected systems. So talk about our response to that. Our next challenge that many of us encounter and will continue to encounter and evolve over the next years will be the topic of cybersecurity. With the advent of smart and interconnected devices, the most vulnerable point of contact for any integrated building system is where it meets the facility's TCP IP network. Ironically, it's this gateway which enhances and expands the system capability beyond the fire network, but also exposes the system to some of its most critical vulnerabilities. And so adding remote connectivity brings about other issues, such as keeping bad actors at bay from logging in and tampering with the fire alarm network. To combat outside threats, ESD4 systems by Edwards provide an integrated UL-listed proxy firewall that uses the advanced encryption standard. The great thing about this is the firewall firmware can be updated without updating the rest of the system, which eliminates the need to retest the system after it's installed. To further reduce risk, things such as programming ports for microcontrollers are disabled during manufacturing, and physical connection points are removed from printed circuit boards. So there are many, many requirements around cybersecurity, and these are just a few that we've taken into account with the new ESD4 panel. And the last topic I want to talk about is backwards compatibility. Because of fire alarm systems representing a significant investment on the part of building owners, reusing field devices, wiring, or other ancillary devices has become a must-have when you're selecting a fire alarm system, as this translates into cost savings. Installation and service of a fire alarm system represents a big financial investment and can be burdensome when undertaking for building owners. At Edwards, we purposely designed and develop our fire systems with a view from a rear view mirror, so to speak, while at the same time looking at what is ahead. With this approach, our fire systems are designed to be backwards compatible with devices going back as far as 20 years, while accommodating newly designed ones. Our systems are also very tolerant of any types of wiring to ensure we reduce the cost of upgrading a previously installed system. And Chris and Rick are going to get into some details about how we're doing that with the notification and detection products. In summary, as an industry, we continue to encounter many challenges when developing and installing fire systems. The changes to codes and standards improve how our systems respond to existing and new fire threats that can be tricky to keep up with. And now I'm going to turn it over to Chris, who's going to provide some additional information on how other elements of the fire system are affected.
Thank you. Thanks, Brian. And before we do that, we're going to have another poll question. So I would ask you all in attendance to please vote on this as well, and we will show the results as we did before. And the question is, for your notification products, how concerned are you with power consumption? Is it a huge issue since they're power hogs for you? Or as power usually becomes a problem? I sometimes run into power issues, or I put as many devices as I want on a loop. So we will also show the results from the audience in a moment as well. So please take a moment to cast your vote and share your experience. And then we'll hear from Chris Hill. Okay, so let's see. In a moment there we go. So 56% said I sometimes run into power issues, followed by 21% power usually becomes a problem. 13% are putting as many devices as they want on a loop, and rounded out by 10% saying it's a huge issue, they're power hogs. So thank you for that. That's interesting. So we'll hear from Chris now. Hi, Chris.
Thank you. And as expected, the majority of people are having some level of power issues with notification products. So we'll talk a little bit about that, what we're doing to address that, and add some flexibility for additional units on a circuit or doing retrofits to expand existing buildings. So first, I want to start with a brief history of notification compliance to highlight the changes we've seen and then discuss changes that are happening today. Before 1992, visual notification was not mandated, and incandescent bulbs was an acceptable form of notification. When the Americans with Disabilities Act was signed into law in 1992, there were many changes. Notification had to be xenon or equivalent. There needed to be a clear lens. The pulse rate needed to be 200 milliseconds or less. The flash rate needed to be 1 hertz minimum to 3 hertz maximum. The devices needed to mount 80 inches above finished floor or 6 inches from the ceiling. And sleeping rooms required 110 candela, 24 inches or more from the ceiling, and 177 candela if less than 26 inches from the ceiling to alert the hearing impaired. In 1999, NFPA mandated that strobes need to be synchronized to prevent epileptic episodes for people with photosensitivity. Technically, if there were only 2 strobes in either direct or indirect line of sight, they wouldn't need synchronization. But practically, since device loops include multiple strobes, and as interpreted by most AHJs, all notification devices needed to be synchronized. Between 2005 and 2007, NFPA did extensive research on what they considered high-risk individuals for surviving a fire event. These were the elderly, hard of hearing, and intoxicated individuals. They found that a low-frequency 520 hertz T3 tone woke 92% of hard of hearing individuals versus only 56% using the standard 3 kilohertz T3 tone. In the 2010 version of NFPA, the requirement for 520 hertz low-frequency devices was introduced, and in 2014, all sleeping rooms for the hearing impaired were required to have a low-frequency device. Continuing to the current compliance changes, the 2016 version of NFPA 72 introduced the 20 millisecond pulse width duration for strobes. The reasoning was based on studies that showed that people will notice a flash in their peripheral better if it's a shorter duration, especially in direct observation. Light intensity was already a part of the standard, but now pulse width matters as well. There was an exception for hallways, which allowed up to 100 millisecond pulse, since you're always in direct line of sight of the strobes one way or the other down the hallway. In 2019, NFPA eliminated the 100 millisecond pulse width exception, and all strobes are required to meet 20 milliseconds. With the elimination of the exception for hallways, NFPA added a rating multiplier to accommodate strobes up to 100 millisecond pulse width. So pulse widths longer than 20 milliseconds, up to 100 milliseconds, are allowed, but the light output has to be more intense to compensate for the longer pulse width. At 100 milliseconds, the candela rating needs to be 3.67 times higher for the same rated area. The 2019 edition also added information about future requirement for bright ambient rooms. Rooms like operating rooms that are always bright need to have different strobe requirements. As it stands today, the code states that any room where the ambient light is above 500 lux reduces the listing spacing by 30% or requires double the light output. This can extend to more than just operating rooms where they can be over 1,000 lux, since the chart NFPA were included for typical ambient conditions had supermarkets listed as 500 or 750 lux and typical offices right at the cusp at 500 lux. The Genesis LED series addresses these code issues and goes beyond to add flexibility. The Genesis LED strobes meet the 20 millisecond requirements and are synchronized within 10 milliseconds of the existing xenon strobes, allowing strobes to be mixed and matched on the same loop and in the same line of sight. This makes the solution ideal for both new construction and retrofit projects. Using the LED in place of a xenon bulb will reduce current draw. But since they are normally power hogs, notification devices needed a drastic reduction in power to make them easier to deploy. With patented lens and LED electronics, Edwards was able to drop the current on a 110 candela strobe from 311 milliamps to just 28 milliamps. That's over a 90% reduction in power. This allows for the flexibility of more devices on a loop, reduced wire size and conduit, longer wire runs for more creative wiring solutions, and reduced booster power supplies. Part of the patented electronics allows the devices to maintain the same current rating regardless of the candela setting. So if an AHJ determines that strobes need to be at a higher setting, there's no panic or power recalculations since the current draw is constant. This makes designing new systems easier as well, since you only need to know the number of strobes and not the setting of each. Another feature that offers flexibility is this quick swap cover skins. The product ships with the color and marking specified that can be easily changed if the need changes. Imagine an entire building is installed with a white product with no marking, and the AHJ asks that it needs to be red with a fire marking. Rather than scrambling to replace products, the covers can be removed and replaced. The cover skins are sold separately for when product marking needs change, or to have extra on hand in case they get damaged or painted. When you're looking for notification devices, look beyond just meeting the code and make sure the product makes your life easier by saving costs, installation time, and offering flexibility as building requirements change. Now I'll turn it over to Rick, who will go over requirement changes for detection.
Thank you. And we will have our third poll before we hear from Rick. Thanks, Chris. And that question there is, are you aware of the new test standards change to smoke detectors and alarms? So is this new information? Are you somewhat aware? Are you closely following this? Or it does not impact you in your role? If you could please answer that, we will again show the results, and then you'll hear from Rick. Go ahead and cast your vote there, please. Okay, so before we get into that section, let's see. 48%, no, this is new information. I'll leave it at that. So Rick, please go ahead. Thank you. Thanks everyone for voting.
Thank you. So, based on the poll question, I think this is probably very timely information for most. So next year, new smoke detector standards will become effective beginning June 1st, 2020. That basically means that any manufacturer who is making a UL-listed smoke detector or alarm must have relisted their devices in order to manufacture after that date. Now, both those test standards, UL 268 for system-connected detectors and UL 217 for standalone home alarms, have the new revisions, and then, like I said, they impact all UL-listed smoke sensing detectors. Among the many changes in both are the addition of 3 new tests, which are really the culmination of more than 10 years of research conducted by various national groups like NFPA, NIST, and Underwriters Laboratories. In this research, burn testing on materials in newer buildings was found that newer materials burn much quicker, resulting in reduced evacuation times for occupants, and dramatically, I mean, roughly from 17 to 20 minutes to less than 5 minutes. So the result of this research was the addition of 2 new fire tests. One, a smoldering polyurethane fire, a slow smoldering polyurethane fire, and a fast flaming polyurethane fire. Both tests have been standardized by UL to represent the newer materials found in modern construction. Now, of the 2, fast flaming polyurethane was really the most difficult for existing smoke sensing technologies that are currently in use. This test fire doesn't have a lot of smoke in the early stages, and by the time it does, the detector is required to have sensed it and gone into alarm. Along the same lines of the research, a nuisance test was also added, which determines a detector's reaction to cooking sources. And again, a separate vein of research was done by UL, by NIST, to profile that. So this test is meant to reduce unwanted alarms where people will disable their detectors to turn off the noise. The test requires the detector not to alarm below a certain obscuration level, and once that obscuration level is reached, it's followed by a fast flaming polyurethane, thus guaranteeing the detector is not too sensitive, but still able to sense a real fire condition. The challenge for manufacturers, smoke detectors, and alarms was that really any single technology such as photoelectric or ionization would really have a difficult time passing all the new tests and achieving the listing. So at AdWords, the challenges that we took on in approaching the new standard were threefold. First, we wanted a cost-effective way of achieving the listing to the new standard. We felt that adding significant cost and thus price just to achieve a listing wasn't something our customers would appreciate. Yes, the change in the standards was better for consumers, fire service groups, and building owners, but there was an inherent belief that they expected this at the same price that they'd been used to. So we knew we had to come up with a solution that wouldn't create significant cost burden for them or us. Second, we wanted to make sure this was seamless for customers. In a sense, nothing was really changing for the customer. Yes, again, due to the standards change, they were automatically getting a better product, but in the end, they still expected a code-compliant product. So whether it was a new installation, retrofit, or maintaining an existing system, being able to transition to the new detectors listed to the new standard had to be painless. This meant that newly listed product had to work with existing systems, and it also had to work in mixed systems with old and new. And to prevent significant conversion or test costs, we didn't want customers to update their fire control panel, its site firmware, or database. And then third, we wanted to be able to add value just beyond simple compliance to the standards. And to that point, the technology that we implemented and the process that we went through gave us an opportunity to really accomplish all three goals. Our path goes back several years to our participation in committee discussions that ultimately led to the publishing of the new standards. We knew then that two things had to happen. One, we had to pick a technology that would be best suited to achieve our goals. And then two, we had to be able to have our engineers be able to test those solutions. To the second point, we put a significant investment in updating our smoke room to closely mirror that of UL's by adding the test apparatus, revising floor and ceilings, doing this in a removable manner so that we didn't lose the ability to test other fire agencies like EN54, for example. We put these changes in place early and in our development cycle, which allowed us to test our solution to a broad range of fire materials outside of really just the UL test fires. We took on a program to look at alternative solutions and assess their impact, and the rapid prototyping solutions got to be tested along the way, giving us the best opportunity to pick the right solution. Now, the most widely used technology in commercial detectors is photoelectric. Our selection of technology came down to a purely optical sensing method that took photoelectric capability to a new level and allowed us to analyze particle size using LEDs with multiple wavelengths and positioning those LEDs at 2 different scattering angles. As we see particles entering the optical chamber, the LEDs are sequenced, and the result of those LEDs flashing is fed into digital filters, software algorithms, all located within the electronics on board the detector. As you can see from the UL chart for the UL study, smoke particles exist in a very specific size range. This technology allows us to measure whether we have smoke particles or nuisance particles, or even a combination of both. This discrimination applies not only to cooking sources, but now also includes some of the most common nuisance conditions that have plagued the smoke detection industry in the past, like steam, fog, dust, and aerosols, including vaping. Now, the concept of using either wavelength or angles is not really new to the industry, but using the combination of both, combined with the proprietary software methods, certainly is, and now it's available really in the most widely used smoke detection device. Our optic detectors were the first spot detectors to achieve listing almost a year and a half before the mandatory date, thanks to the process that we used and the early recognition of our leadership of the significance of this change. With careful addition of extra optical components, onboard software filtering, and algorithms, with fire room testing, optic detectors were capable of achieving a listing to the new standard without the use of other sensors like heat, carbon monoxide, among others. Plus, now we're able to discriminate many of the nuisance sources that have plagued smoke detectors in the past. Because we are making all of the alarm and nuisance decisions right there in the detectors, we can easily communicate to our Edwards fire control panels in the same manner we had with previous generations of Edwards detectors, making it easy to transition existing projects and detectors without burdening them with site programming changes or extra testing, and it gives the customers the continuity they expect. For building installed with Edwards systems, whether it's just replacing one detector or expanding the system due to renovation, we can now provide a seamless path forward, mixing old and new. And then the last thing I'll leave you with is we had, prior to the release of our Optica detectors, the chance to trial this technology in a real site. The site we chose was a dormitory housing project on a university campus that had significant issues with cooking nuisance alarms. These 3-story units had a detector on each floor, with the cooking area on the first floor. The first floor detectors were replaced in this system with Optica detectors, and the impact was immediate. Prior to the change, they had something in the neighborhood of 5 to 20 nuisance alarms a month. Afterwards, this dropped to 0 for the newly installed Optica detectors. It was a great testament to the result of efforts that our team made in the design. So with that, I thank everyone for taking the time to listen to our presentation. We hope this information was useful to you, And we will now turn it back over to our moderator for questions.
Great. Thank you very much, Rick and Chris and Brian, and thank you for the information and to our audience who has sent in questions. So yeah, we do have some time for some Q&A, so I will get right to that, and we'll pose that to all of you, whoever wants to jump in. So the first question we had from the audience regarding the last part of the presentation here on the new notification testing requirements that you talked about, Rick, but of course open it up to any of you gentlemen. The question is, will the new notification testing requirements force a system-wide replacement of previous units? I'm sure that's a common question in the audience and throughout, so can you please talk about that? What will the replacement requirements be, if any?
Yeah, so for notification requirements, I think this question's about the change in the standard to NFPA, talking about light above ambient. So we don't know for sure how that's going to end up being in the code. Right now they're looking at it. What we do know is there's a precedent set for sound above ambient to be 15 decibels above the ambient sound. So most likely we will be taking a light above ambient approach in NFPA. So right now they're investigating it. My guess would be it would be on a sliding scale for candela output increase based on ambient lux in the room, and that they'll specify that. What I would like to say though is our devices, being the fact that they have the exact same current draw regardless of candela output, give you the flexibility to increase the candela output without having to change your system design. So in the case of our notification appliances, you're going to be able to make those candela changes without having to swap products. We don't know exactly what the NFPA is going to decide, but we've built that flexibility into our notification product.
Thank you. So then going back to the beginning of the talk here, and Brian, you were talking about codes and the different changing codes in compliance. So the question was from the very beginning is, does the codes have a requirement that a system must be changed out after a certain number of years, or is there more of a factor of keeping up with the latest technology? So do the safety codes require a certain number of years? You change it out on a timeline like that, or is it, again, more of a factor of keeping up with the latest technology? What kind of facility?
So no, they do not. That's the short answer. Generally, the systems are grandfathered in as compliance, unless there's a couple of different conditions whenever they would require a replacement. So if a significant portion of the building is renovated, then it must be brought up to code. That's one situation. Two would be if the laws of the jurisdiction require an update due to a special circumstance. So, for example, there are now carbon monoxide monitoring requirements or mass notification. Those would be a couple of times when that would happen. Or three would be if the building fails an inspection. So those would be a couple of scenarios. Otherwise, generally the systems are grandfathered in.
Thank you. Then I have another question about equipment replacement and looking ahead to the notification changes, the 7th edition requirements and the notification changes that were discussed. So the question is, will the systems that I'm installing today, if you're midpoint in a project or considering a project, will they need to be replaced when the 7th edition requirements are effective? Or what should someone do who's maybe midway or somewhere at the stage of a replacement project? What should they do and think about?
So the short answer is no. Everything that's being installed today, and really everything that is purchased for installation in a building prior to the effective date, is completely listed product, and there's no concern about having to replace it.
And to clarify, that's for detection.
For the detection, correct.
Thank you. And then I'm going to switch gears just a moment. There was some talk about cybersecurity, and that's certainly a concern with all the different technologies and building systems these days. So the question was, you had talked about the EST4, the Edwards product system. So the question was there, how does EST4 help ensure cybersecurity? Can you talk about some of the, I know you addressed it, but can you talk about some of the characteristics that are in there or some of the measures that your products take to ensure cybersecurity?
So primarily, that's as I talked about, there are a number of changes in the manufacturing process that we do, disabling ports, things of that nature, where it's actually reducing the attack surface of the system. But primarily, the way we do that is through our firewall. So we actually have a UL listed firewall that's part of the EST4 system, and our plan is to regularly release updates to that so that you're protected from the latest threats. And as I mentioned, one of the advantages of being able to do it that way is that you're not by code changing the executive software for the system, so it doesn't require a retest as you would if you were doing a change to the panel configuration or executive software. So it's our approach. We actually have, if you're interested in the cybersecurity aspects, we should shortly have a white paper with a lot of the different details of all the different things that have done. It was a pretty significant effort, and we've got a lot of those details that we'll be publishing, and we'll be sharing those. So as I mentioned too, it's going to continue and to evolve over the coming years, where there's obviously going to be new threats out there that creative programmers come up with, and we're going to have to be on the other side of that to protect our system. So I think we've got a good way to do that going forward.
Okay, thank you for that. So another question. Let's see. We'll talk about I did want to ask you a quick question about the last slide, right before this question slide. Rick had been talking about nuisance alarms, and I think that's a concern with a lot of facilities people that we run into. I hear a lot about that. So I just wanted to ask you, Rick, could you quickly just review the Optica detector and the characteristics that go into that detector, addressing specifically the nuisance aspect of it? I was wondering if you could review that.
Yes, certainly. So in the Optica detector, we've taken the approach. Standard photoelectric really has kind of a light emitter and a light receiver. It's usually been one wavelength, and really, for the most part, anything gets in the middle of that to a certain level, the detector goes into alarm. In the Optica, what we've done is that we've added, 2 forward scattering LEDs, one at different wavelengths, and then a backscatter LED as well. And what that does is basically now gives us the opportunity to flash each of those LEDs differently, or in sequence, and the result gives us an opportunity now to analyze the size and the type of particle that's in the chamber. And then we take that result and, using the software algorithms that we have in place, we can determine now that, what that detector is seeing from that result is what is a nuisance size particle, or it's a fire size particle. Hopefully that answers the question.
Thank you. Thank you very much. And thank you, everyone, for sending in your questions. We do have time for probably one more question. So I wanted to go ahead and ask you, I wanted to circle back to the new requirements that you had talked about at the end of the presentation. And we talked about how their new systems, existing systems, will not need to be completely replaced, as you had explained. But with that in mind, will there be replacement parts available for systems that are currently installed? In other words, is there a matter of where a facilities person could update their system to comply without necessarily replacing the whole system? Are there recommendations there as far as new equipment that they may want to put in to comply and be up to date?
So, we went through for installed Edwards systems. We went through a painstaking process of making sure that we were backwards compatible, so that if it after the date became effective, we could replace old detectors in those Edwards systems without being concerned of updating, system firmware or retesting or such like that. Now, for other systems, I can't really answer that. That's outside my.
Okay. Thank you. Actually, we do have time for a few more because I see some coming in, so I will squeeze those in. And the question was, how do I get, this is more of a asking out resources in the industry from Edwards. How do I get more info on how to interact new equipment with the existing equipment? So, integrating existing equipment with old equipment. Are there resources that Edwards might have available, or NFPA? Anything you can recommend offhand?
I would say on that one, with how our systems work together with new technologies, old technologies, we've tried to make them so that you can easily retrofit, you can easily add on to a system. So a lot of that's covered in our UL documentation as far as what's allowed and what's not allowed. So you can find that in our installation sheets for our equipment. But I'd probably refer you to somebody within our organization that we can get you in touch with if you want to.
Yeah, I would certainly recommend starting with go to our website. We'll try to get somebody in our sales channel or our strategic partner channel to talk to you more.
Okay, and you'll have that information there, gentlemen, so we can connect you there. And then lastly, computer room fire protection. We'll go a little specific for a moment, and then we'll wrap it up. The question was, I have interest in computer room fire protection. Any comments there? So is there any kind of, new trends or new products that you have available, or, any advice that you see in your work with, computer rooms, server rooms, and fire protection that you might want to leave us with?
Sure. So, yes, so we're seeing quite a few projects along those lines recently here, and we didn't really talk about it today, but a number of our products interface with things such as aspirating detectors that are out there that are used for that application. So we have many different ways to do that, and we have an applications group that's involved heavily in that as well. But that's certainly a trend that we're seeing, and we're specifically tailoring some of our products to meet that application.
Great. Thank you very much. Well, thank you, everyone, for sending in your questions. We appreciate that. If we did not get to your question, we will be able to answer those offline. The gentleman here will be able to answer you directly offline, so be assured you will get an answer. I want to thank you, gentlemen, for your presentation. Thanks for your time today.
Thank you.
And also, thank you. And also to Edwards for sponsoring the webinar, of course. We will have a recording of this webinar available along with the slides online at facilityexecutive.com. And also please check out Edwards' website for more information. There's a plethora of information there. And that's edwardsfiresafety.com. So thank you and have a great afternoon.